Polynomial curve fitting. Welcome, dear students. Numerical Practical number 23 by C Programming. Polynomial curve fitting. Fitting a polynomial curve. Polynomial curve fitting by least square method. Write a C program to fit a curve of the form y equal to a plus b x square to the following data using least square method, where p equal to r by 10 and r is the last digit of your serial number. Here the data for x and y, this is y minus p. So y minus p equal to 6.25. So y equal to 6.25 plus p. Actually here 6.25 plus p, 8.98 plus p, and so on. Now this is a note from IGNOU, a beautiful note for fitting curves, and this is the principle of least squares and so on. I will provide this note in the description box, and you can study this note and this. And let us suppose x1 y1, x2 y2, xn yn be n pair observations of the variables x and y. That is the bivariate distribution. This pair to fit a polynomial curve of degree n, say here n equal to 3. This is the small n. Note down this degree of curve is small n and the number of data is capital N here. So y equal to a plus bx plus cx square plus dx cube, where d not equal to 0. Otherwise, if d equal to 0, then this curve reduced to degree 2. By the method of least square, we have a system of normal equations of 1, this na plus b summation x plus c summation x square plus d summation x cube equal to summation y, and this 4 equations, where summation notation, actually summation runs from I equal to 1 to capital N number of data. The method of least square, actually here if S denotes the sum of the squares of the residuals, then S equal to sum I equal to 1 to capital N bracket a plus bxi plus cxi square plus dxi cube minus yi whole square. Actually we want to minimize this S, and from the calculus we have this for minimization, this del S by del N partial derivative with respect to a of S, del b of S equal to 0, del c of S equal to 0, del d of S equal to 0. And these are the above 4 normal equations, these 2.1, 2.2, 2.3 and 2.4. And these are the normal equations of this. We want to solve this system 2 for 4 unknowns a, b, c, d. There are 4 unknowns here. So for C programming, to solve this system, above system, for fitting a polynomial of degree n equal to 3 here, small n, we must calculate 2n plus 1, that is equal to n equal to 3. So 2n plus 1 equal to 7 constants. This is the notation. Sx0 equal to the summation xi to the power 0, that is equal to constant 1. So obviously this is equal to the number of data capital N. Sx1 equal to summation xi, Sx2 equal to summation xi square, Sx3 equal to summation xi cube, Sx6 equal to summation xi to the power 6. So left hand sides, the equation of the left hand sides, the summation x square, summation x cube, and lastly summation x to the power 6. we get by this notation is this. And for the right hand side, this right hand side, this summation y, summation xy, summation x square y, summation x cube y. So we write this s y x 0 is equal to x summation x to the power 0 I yi, that is equal to summation yi. S y x 1, that is equal to summation x y. S y x 2 summation x square y. S y x 3 equal to summation x cube y. So the above system can be written as this a into sx0, b into sx1, c into sx2, d into sx3, and so on. Again renaming the system, above system, this a into b00. So sx0 equal to called b00, b into sx1 called b01. So in this way we get this a b30, b3 b31, c b32, d b33 equal to b34, where bij equal to sx I plus j. I and j both runs from 0 1 to n here 3 here, and bin plus 1, that is bi4, that is b04, b14, b24, b34 is equal to syxi. This is syx0, syx1, syx2, syx3. And then we solve this system by Gauss elimination method. Alternative way, in particular case, if we want to fit a polynomial of degree 2 with coefficient of x equal to 0, a plus bx square, here coefficient of x is absent, so the b not equal to 0, we have a system of normal equations of one, this in a plus b summation x square equal to summation y, and a summation x plus b summation x cube equal to summation xy. Let sum x equal to summation x, sum x2 equal to summation x square, sum x3 equal to summation x cube, sum y equal to summation y, sum xy equal to summation xy. Then the above system becomes a n plus b into sum x2 minus sum y equal to 0, and a into sum x plus b into sum x3 minus sum xy equal to 0. By cross multiplication method, we get a by this, a by this into this minus this into this coefficient, this b by this into this minus this into this, so and constant 1 by this into this minus this into this. So a equal to this, b equal to this. Assume here this denominator not equal to 0. In this programming, the integer variables are n, I, and r. N is the number of data. Here, the number of data, there are 8, n capital N equal to 8, and r is the last digit of your serial number, and float variable a, b, p, x 200 and y 200, and float variable sum x2, sum x3, sum y, sum xy. Now we enter the value of r. If you wish to enter these values x and y in this way, otherwise you can delete this portion, slash start to start slash up to this portion, you can delete this. Here capital N equal to 8, total number of data here is 8, and p equal to r by 10.0, and the given data for x, x0, x1, x2, x3, x7, and y0, y2, y7, and this from the given data we write this. These are the separate list for data. We now delete all these data. This Initialize this sum x equal to 0, sum x2 equal to 0, sum x3 equal to 0, sum y equal to 0, sum xy equal to 0. For I equal to 0, I less than n, I plus plus, this sum x equal to sum x plus xi, sum x2 equal to sum x2 plus xi into xi, sum y equal to sum y plus yi, sum xy equal to sum xy plus x into y, sum x3 equal to sum x3 plus x cube. And solve the normal equation. This sum y equal to na plus b into sum x2. The normal equations this the normal equations an plus bx2 minus sum y equal to 0, this. So here note that this polynomial is a plus bx square, so coefficient of x here absent, and this a equal to this and b equal to this, and print this required polynomial curve is this. So we compile and run this. R equal to say 0, total number of data equal to 8, and the required polynomial curve is y equal to 7.64678383 plus 0.40404773 x square. Now uh, this is a alternate problem. This either you write this problem, or if this is the easiest problem, this the particular y equal to a plus bx square, and this problem is more generalized here. This first we create a function, Gauss elimination, void Gauss elimination, voice Gauss eli, integer m, float c is matrix C matrix, and float z is the variable C matrix, augmented matrix is this. M is the number of rows of the augmented matrix C, and this integer ijk, and for this I equal to 0, I less than m minus 1, this for k equal to this, and float term c ki divided by cii, and for j equal to 0, this c k j equal to ckj minus term into cij, and begin back substitution, and so we solve this z. So this is the function for Gauss elimination. Integer main program, float variable p x 100 dimension, y 100, b 100 in 100, a 100. Integer variable ij, integer capital N is the total number of data, integer small n the degree of the polynomial curve, integer r the last digit of your serial number. Enter the value of r. This n equal to 8, the total number of data is this, p equal to r by 10, and x0 up to x7, y0 to up to y7, and delete at this moment, delete all these data. Now here is the integer variable choice. Printf choice 1 to fit parabola y equal to a plus bx square. Choice 2 to fit polynomial y equal to c plus bx plus ax cube. The cubic polynomial, and note that here the coefficient of x square is absent. And the first choice 1, coefficient of x is absent. Choice 3, fit the nth degree polynomial this. So either straight line or parabola or cubic polynomial or higher order polynomial. Enter your choice. Scanf this. Here, according to our given problem, here a plus bx square polynomial is this. Uh, so we choose this choice 1. Enter the degree of the polynomial to be used. This is the small n here. So a plus bx square. So obviously small n equal to 2 here. Here the array Sx of size 2n plus 1 for storing in some x2 and etc etc. So float Sx 2n plus 1. So float Sx 2x plus 1. So this float Sx is this. This is the float Sx 2n plus 1 7 constant for n equal to small n equal to 3 polynomial degree 3. So Sx0, Sx1, Sx2, Sx3 up to Sx6 here. So is the Sx 2n plus 1 for I equal to 0. Initial Sx I equal to 0, j equal to 0, j less than equal to n. Capital N is the number of data here. And this is xi new value equal to old value Sxi plus power x to the power I. So when I equal to 0, so this is the Sx0. Sx0 this is equal to n. When I equal to 1, and this is the Sx1, that is the sum x, summation x. Sx2, that is the sum x square, power x square. And right hand column vector, this is the syx for storing sum y, sum xy, sum x square y. So from this right hand vectors this. So syx, syx1, syx2, syx3. So right hand and side vector this is sum y, sum xy, sum x square y, sum x cube y. So double syx n plus 1, this n equal to 3. So here say n equal to 3. So this dimension is 4 here. This n plus 4, this n plus 1 equal to 4 because we choose here n equal to 3. This syxi equal to 0, syxi plus syxi plus power, that is x to the power I into y. So syx equal to sum y, syx0 equal to sum xy, syx2 equal to sum x square y, summation x square y. Switch choice. Case 1, if choice equal to 1, we want to fit the parabola this y equal to a plus bx square. So here b00 sx0, b01 sx2, p02 sx, syx0, this is the augmented matrix. Actually this b matrix is the augmented matrix. So this is the b00, b01, b02, b03, b04, b10, b11, b12, b13, b14, and this is for n equal to 3. So when n equal to 2 and this b equal to small b equal to 0, a equal to this, so accordingly you write this. So b00 sx0, b01 sx2, b02 sxy0, and so on. Now we call the function Gauss elimination 2ba. So this is the 2 is the number of is the m is the Gauss elimination, call this integer m. M is the number of rows of the augmented matrix C. So here m equal to 2 because 2 rows only, and this is the float C. Here the augmented matrix B, capital B, and the variable we call it capital A. So this is the 2ba. A is the this A is small a equal to a0 and small b equal to a1. To fit this constant term a equal to a0 and b equal to a1 and break. Case 2, this fit a polynomial curve this y equal to c plus bx plus ax cube. Note that here coefficient of x square is absent here. Here c is the constant term a0, b equal to, this is the coefficient of x, and a is the coefficient of x cube. Augmented matrix B of the normal equations, this B00 first row, this is the first row, and this is the right hand column vector, this, and this is the B00, B01, B02, and so there are 3 rows. So call the Gauss elimination these 3 rows 3, and B is the augmented matrix, and A is the corresponding variable to I want to determine this. So fit a cubic polynomial, we get this, the constant term C and the coefficient of x b, that is equal to capital A1, and coefficient of x cube, that is equal to A, and this is equal to A2. Case 3, the more general case for nth degree polynomial. This same as this. This the define this Bij equal to Sxi plus j. B00 n, B01 sum x, and so on. And the right hand column vector is Bin plus 1. So this is the Bij equal to Sxi plus j, ij 0, 1 to n, and Bin plus 1 equal to Syxi, and this is the right hand column vector, this right hand column vector. So we find this Bij and Bin plus 1, this. Now we call Gauss elimination this n plus 1, and there are n plus 1 rows. Note that in this polynomial degree, no coefficient is absent here, and so I call this the printf y equal to this, and print this aij, break, and this end. Now compile and run. Enter the value, say r equal to 0. Total number of data in capital N equal to 8, and choice 1. So choice 1, fit y equal to a plus bx square, fit polynomial y equal to c plus bx plus x cube, and fit nth degree polynomial this. According to our problem, we put choice equal to 1. Next, enter the degree of the polynomial to be used. Obviously, y equal to a plus bx square. So obviously, this the polynomial degree is 2. So enter 2. So to fit a parabola y equal to a plus bx square, where the constant term a equal to 7.646788 and coefficient of x square b equal to 0.404048, and compare with the previous programming, and this programming, this same problem, enter the value r equal to 0, and this, so compare we this is the constant term here, a equal to 7.64678383, and this the coefficient of x square is the 0.404048, here also 0.40404773 also. So both methods are same, equivalent. This is the more generalized method. This this is the more generalized method, problem 23, and this is the extra problem 23.3, and all are given in the description box. And thank you for watching this video.